In this lesson, we're going to be reviewing fractions, especially the concept of equivalent fractions. Now, for this, it's going to be important we remember the words numerator and denominator, so we can use those two words properly. In a fraction, the top number is called the numerator, and the bottom number is called the denominator. And this fraction would look like this, 3/5. And the reason is that the denominator here, that tells us how many pieces would make up a whole. So that's why the whole thing split up into 5 pieces, and that's the denominator, and the numerator here, that tells us how many pieces we actually have. That's why only 3 of the 5 pieces are shaded. So that's the numerator and the denominator. It's important to remember what they actually mean. The next thing is the highest common factor, and if I wanted the highest common factor of 15 and 20. Now remember, factors are numbers that go into it, so the factors of 15 are 1, 3, 5 and 15, because all those numbers can be divided into 15 with no remainder, and the factors of 20 are 1, 2, 4, 5, 10 and 20, and the highest number that's on both of those lists, so the highest common one, is 5. So we would say the highest common factor of 15 and 20 is 5. Now unless the actual question is find the highest common factor, just like it is there, then you don't need to show all this working. If you just need to find the highest common factor to answer a different type of question that's focused on something else, it's fine to do it in your head, and really the question you're asking is, what is the highest number that goes into 15 and 20? If you can think of that, then you'll get your answer straight away. Of course, it's 5, but always try and make sure you get the highest number, not just any number that goes into both of them. Let's now look at what it means by equivalent fractions. So I'm going to put a fraction on the screen here, and it is 3/5 in total, because there's 3 shaded sections and 5 sections altogether. And notice that each section is also exactly the same size. That's very important. That has to be the case. And so if I cut this down the middle, notice that now I've got more sections that are exactly the same size. Instead of 5, now there's 10 sections in total. 6 of them are shaded, but what's really important is the amount of shaded area did not change. It's exactly the same, and the amount of space the fraction takes up here did not change. And that means that 3/5 is exactly the same as 6/10. They have exactly the same value, even though they're using different numbers there. And the way we got to 3/5 to 6/10 is, notice I doubled the 3 and I doubled the 10. And the key thing here is that if you take any fraction and you double the top number and you double the bottom number, you're going to get another fraction that's worth exactly the same amount. And it doesn't have to be doubling. You can times it by 3, by 100, by a million, whatever you want to, as long as it's the same number on the top as on the bottom. So if I was to take 3/5 and I times the top and the bottom by 3, I would get 9/15. 9/15 is exactly the same value as 3/5. I could do the same, but times it by 10. 30/50 also has exactly the same value as 3/5 and as 9/15. All these things have exactly the same value. 3/5 times by 25 on the top and the bottom is 75 over 125. And so that means if one person said, do you want 3/5 of a pizza, and another person said, do you want 75 125ths of a pizza, they're actually offering you exactly the same amount. And so when you multiply or divide, it works in reverse as well. When you multiply or divide the numerator and the denominator by the same number, it has to be the same number, you get an equivalent fraction. You get another fraction that's actually worth exactly the same amount, even though the numbers are different. Now let's go to another fraction, 8/12, and so we'll get it on the screen here. And what I'm going to do is I'm going to cut this down the center here. I'm going to get rid of that middle section, and notice now I've got another fraction. Again, it takes up exactly the same amount, so it's got the same value, and it is 4/6. So I write down 4/6. Now notice I've just done the opposite of what we were doing before. Before I was timesing, now I'm dividing. Now I've halved 8 and I've halved 12. And I can actually do that again on this fraction here. If I take out this line here, and this one here, and this one here, so every second line, then notice again I end up with now 3 equal sections. Remember, the key here is I need equal sections. I couldn't just take out this line here, for example, because then this section here would be much bigger than that one. But as long as I've got equal sections, and as long as the shaded area is taking up exactly the same amount, I've got another equivalent fraction. And so this one is 2/3. And so 8/12 is the same as 4/6 and the same as 2/3. And again, notice to get from 4 to 2, I have just divided by 2. Same with getting from 6 to 3. I've just divided by 2. And so when you divide the numerator and the denominator, that's actually called simplifying when you're going downwards, when you're dividing. And the reason it's called simplifying is because you're making these numbers smaller. You're making them simpler numbers. You've turned 8 over 12 into 2 over 3. And if we do get as low as possible, now by as low as possible, I mean you can't divide 2 and 3 by anything else. There's like I said, I can't take out this line here. There's no more lines I can take out of this fraction and still have equal amounts. And so that means that it is fully simplified. I can't get these numbers any lower. There's nothing left to divide. Now I don't always have to divide by 2. Let's put our fraction back up and let's go back to 8/12. Now I just divided by 2 here because I took out that middle line. But let's forget the fraction for a moment, the drawing. Let's have a look at the numbers. What is the highest number that goes into 8 and 12? Remember, that means we're looking for our highest common factor of 8 and 12. The biggest number that goes into 8 and 12 is 4. 4 goes into 8 twice, and it goes into 12 3 times. So I'm just going to go straight to dividing them by 4. And so notice that gets me straight to 2/3. It gets me straight to my answer. So we're usually interested in fully simplifying, which means that whenever we try and simplify a fraction, we always look for the highest common factor. We look for the biggest number that goes into both so that we end up straight at our answer. And of course, on my fraction here, because I was dividing by 4, that means it just goes straight to that instantly because I divided the number of these shaded pieces by 4 and I divided the total number of pieces by 4. Now if you did happen to not get the biggest number straight away, we can see here that it's okay, you can just keep going. You do end up at the final answer. And so let's say I was looking at 8 over 12 and I thought, well, what's the biggest number? And I thought it was 2 and I divide it by 2. When I get 4 over 6, I just have another quick look at my answer and I go, well, is there anything else that goes into them just in case? And in this case there wasn't there? There was 2. Whereas here, when I've done divide by 4 and I look at 2 and 3, I just go, just in case, is there anything else that goes into 2 and 3? No, then I must be at my final answer. It's now fully simplified. I can't do anything else. Let's look at some examples now that use equivalent fractions. So starting with rewriting 2/3 with the denominator of 18. So let's start by writing down 2/3 and then I have to turn this 3, the denominator, into 18. And so I can do that by multiplying it by something. It has to be multiplying or dividing, and I'm not going to divide because I've got to make it a bigger number. So I'm going to times 3 by something. Well, it's by 6. 3 times 6 is 18, and so I can do that as long as I do it to the top number as well. So I've got to do it to the denominator and the numerator, because then I'll get a fraction, remember, that's worth exactly the same value even though its numbers are different. And so I end up with 12 over 18, and so now I've got a new fraction that has the same value as 2/3 but has a denominator of 18, just like the question asked me. And you don't really need to write down these times 6, by the way. That's why I've done it in green there. You can just do that bit in your head, or you can write it down if you'd like to. Now in the next one, we need to find the missing value in this box here, so the numerator. So let's start by just writing down that question exactly as it is, including the box, so I know where I'm going to put my answer. And then we just got to realize this is actually the same idea as the previous question, where now we know that I've got to turn the 5 into 20. And so how do I turn the 5 into 20? I times it by 4, and that tells me what to do with the top number as well. So over here the question said write it with the denominator 18. This one, it just gave me a denominator of 20, but it's the same idea. So 5 times 4 would get 20, so I have to times the top by 4 as well, and that means it's 16. Once again, there's no real need to write down those times 4s, just the question, and just put the answer in is fine. Now another form you might get for that question is when it's got multiple fractions and you've got to fill in all the boxes. That's okay, it works exactly the same way, it's just you've got to do it with more fractions. So how do I get from 5 to 10? I times by 2, so I times the 4 by 2, put my answer in. How do I get from 10 to 20? Times by 2, times the 8 by 2, I get 16. How do I get from 20 to 40? Times by 2, times 16 by 2, and I get 32. Seems straightforward so far. It can also happen with the denominators, and you can end up with another little problem as well, which we'll show you here. So 4 times 2 is 8. So that means I times the 5 by 2 and I get 10. But then 8 times, wait, you can't times 8 by anything to get 20, at least not any whole number. So what do? What I do is I ignore this fraction entirely. Since they're all equal, it means I can go back to my original fraction and go, well, how do I get from 4 to 20? And since I'm timesing by 5 to get from 4 to 20, that's what I do to the denominator as well. I times it by 5. And then again, I can't go 20 to 36. I can try going 8 to 36. That doesn't work either. Can't times 8 by a whole number to get 36. So again, I just go back to the 4. 4 times 36 is 9. 5 times 9 is 45. I said that wrong. 4 times 9 is 36, not 4 times 36 is 9. So 4 times 9 is 36. 5 times 9 is 45. In the next one, we're writing 12 over 16 in simplest form. Now this simplest form, that just means the same as make it fully simplified. And so remember, I'm looking for the highest number that goes into 12 and 16. And so I start by writing down the question, what goes into 12 and 16 without remainder? And the biggest number I can think of is 4. And so I divide both of them by 4, and 4 goes into 12 3 times, and it goes into 16 4 times. And so that's my final answer there in simplest form. Now, what if I was doing that and I didn't realize that 4 was the biggest number that goes into 12 and 16? What if I thought it was 2? So I divide them both by 2 and I get 6 over 8. Well, that's okay. That doesn't mean I'm wrong. It just means I'm not finished yet. Remember, we should always look at our answer, what we think is our answer, and see, is there anything else that goes into these two numbers, just in case I didn't get it right the first time. And I can see, okay, well, 2 goes into 6 and 8. So now if I divide them by 2 again, then I end up with 3 over 4. Notice I got the same answer as last time. It just took an extra step. So while it's better to always get the biggest number we can to start with, if we don't, we're not necessarily wrong as long as we look at our answer and realized, oh, I'm not finished because there's something else I can do. Let's try some practice questions with that now. Remember to pause the video. And there's our solutions. Notice I didn't bother writing down the green numbers, the times bys, the divide bys. If you wrote them down, that's fine, but I didn't worry about putting them there in my solutions. So just checking your answers, make sure you've got them right there. Now in this first one, we had to rewrite 4/7 with the denominator of 14. So I wrote down 4/7 and I thought, well, what do I have to multiply the 7 by to make it a 14? Because of course that's the denominator down the bottom. And so I had to times it by 2. And if you times 4 by 2, you get 8. So that's why the final fraction is 8 over 14. In the next one, when I'm looking for the missing number, remember it's exactly the same idea as the first question. This time they're just telling me the denominator's got to be 21 using this method instead of writing it in the question like that. So they're saying 3's got to turn into 21. I have to times it by 7. So I have to times the 2 by 7 as well. And that gets me 14. And in the last one, we're going to write 18 over 24 in simplest form. And this is where you've got to look for the highest number that goes into both 18 and 24. You might think that 3 goes into both 18 and 24, and it does, but that's not the highest number. You want to get the highest number, which is 6. And so if you divide 18 by 6 and divide 24 by 6, you end up with 3 over 4. Here's some more practice questions if you needed another go at some of them. Remember to pause the video. And there are the solutions to that. Hopefully you got them right this time, but if not, remember to get some extra help. And that brings us to the end of the lesson.